Hello, my name is John Mullins. I'm a senior biochemistry major at SFA, and my project was investigating the potential interaction between two plasma proteins, serum albumin and Fetuin-A. Serum albumin comprises more than 50% of all the proteins found in the plasma. It's the most abundant protein in the plasma. And previous bioinformatic analysis using string, which is a predictive algorithm that searches for interactions with other proteins in the plasma, revealed a consistent link with Fetuin-A. And this was consistent among several different homologs of albumin. Fetuin-A, also known as AHSG, is a glycoprotein that's significant because it's the only other protein other than insulin that binds to the insulin receptor. And there have been several studies that show there might be a possible interaction between the two, but it has never been investigated and experimentally determined. So our hypothesis is that serum albumin modulates the steady-state concentration of variously glycosylated forms of AHSG through direct physical interaction. So this experiment first sought to establish that an interaction is occurring. This was done using several biochemical methods. The first was using a pull-down assay, and we used two different types of resins, nickel NTA agarose resin and an anti-His affinity resin, which upon introduction of the first protein, Fetuin-A, has a polyhis tag, covalently binds to a ligand which is connected to the resin, and then your second protein, in our case albumin, is passed over it, and if there is any binding occurring, the complex can be eluted and resolved on an SDS page gel, which is what we did for both types of resins. The results were pretty conclusive. They suggested that some binding was occurring. However, there was significant background binding between HSA and the resin that casted some doubt on the validity of this data. The next method that we used was called Western blotting and chemiluminescence. And the way that this works is that Western blotting uses two different types of antibodies that will bind to our HSA and can be visualized using chemiluminescence. The advantage of using Western blotting is that it's a much more sensitive technique. It can detect proteins on the order of picograms. And so we lowered the concentration of both of our proteins and diluted it up to 100 times from the original. And this significantly, almost completely removed the background binding, which increased the signal-to-noise ratio of our results, while still showing that binding was occurring. So the results of this were much more conclusive. Some future work that we want to do is modifying the pull-down assay and the Western blotting, maybe by switching the His tag on each protein. We also have some ongoing research using SPR, surface plasmon resonance spectroscopy, to detect and quantify the binding and also perform kinetic analyses. And we also hope to use gel filtration chromatography to detect binding. Thank you.